Hey, what's up, everyone? How's it going? It's Papa Bale, and I went to the gym earlier, and it felt great. Um, you guys were with me then, and if you were, we were looking at a series circuit, and we got up to around 2,500 RPMs with the series circuit. Um, right now, I have it hooked up in parallel, three transistors. I got a whole like 3 packs of tip 42s. We can do whatever, and we can be pretty careless through at least one of these packs. So let's turn it on and see what kind of torque we get. Hi.
Hello. Did you get a haircut?
No.
Looks like you did.
No.
Your hair looks a lot different though.
Yeah. I wanted to get a haircut.
I want to.
So this is 4 volts in. We're drawing 0.6 amps.
What do we got?
What do we got? So this is a parallel connection. Each one of these coils is hooked up to its own transistor. It is a tip 42 though. It's a medium switching, it's not fast switching, so we're somewhere in the middle here. This is around 4.5 volts, 0.8 amps. With the parallel connection, we will be drawing more amps. So I'm going to put it up to 5 volts, 1.4 amps. $1,330. Yeah, 1,300. At 5 volts, I say 1,300 is pretty good. These coils are awesome. I've been doing it all wrong. But it was fun, experimenting with different size coils, types of coils. So these are large iron cores. You got half an inch diameter and 4 inches in length, and then they're covered in 2 layers of 20 gauge. I don't know exactly how many turns, but if you do 4 inches at 0.0315, you can figure it out pretty easily. Yeah, I just wrapped it up real quick, and since I have all the other dimensions, it's going to be easy to figure out the amount of turns if I need to figure that out. Alright, but that's not really important. Put it up to 6. 6 volts. 2 amps. We're going to hit 2,000 RPMs right now. (2006 RPMs). 12 watts to get that. So we got 6 volts in and 2 amps.
That's about 19 amps.
No, 1.9. 19 amps would be, stuff would be on fire. The wire that I got.
Oh, someone's saying $5.
Awesome. Oh, what up, Chris? Thanks, my man.
You should like his comment.
Go ahead.
You should like it.
I think I can manage.
You gotta hit the heart, I think.
Uh,
Or hit the, You gotta hit the like sign or the heart sign.
Bam, I got it. All right.
I was thinking the heart because if you had TikTok, the like button was a heart.
Okay. So, I have a feeling that there's a trade-off. With the parallel circuit, you can get going faster at less volts with more amps. And then with the series circuit, it's more volts with less amps. But 2500 for the series circuit, and I think to get to 2500 we might have a meltdown with the parallel circuit. But we're really close. We're like 2100. At 6 volts though, that's awesome.
Okay, there's a reason why there's 4 seasons and 12 months. Because every season is 3 months.
Yeah, pretty much. That's pretty good, Kevin.
I mean, it's in between March and February because winter is until March 19th. I mean, you gotta care what it is because you still have to guess what if the
6.5, 2.4 amps. And we got 2252. 2263.
I can not even
6.5 volts. That is crazy.
I can not even see
Don't
it
touch
moving.
that.
I can't even see it moving.
2275.
22 volts.
No, that's how fast it's going per minute. $23.78, 2400. Woo! Man, that parallel circuit is kicking butt.
Can I try? Because I want to see.
2444. Yeah.
It's literally right there.
It's like a grinding saw, man. It's awesome. Woo! Man, that's pretty fast.
Yeah.
But we have a goal of reaching 5,000.
Just by seeing how fast this was, it looked like it was completely not moving.
Kinda.
I can just hear the noise and that it was not moving. We gonna turn it back on?
Yeah, and the reason that I know that it's not just the fact that this rotor is light. I tried all my other rotors with these coils, and these coils are awesome. They're really good for moving things fast.
They're super tiny, and I don't think this one is part of that because this one is too big to fit that rotor.
Well, not really. Let's see. If we turn it like this, and put it in here like this.
So the coils are like things that make the thing spin faster, or maybe it's just for magnetic for making it spin faster.
I don't know what that means, buddy. Yeah, the coils. It's really, it'd take like an hour for me to explain it to you exactly, but you put some energy in the coils and you get a magnetic field.
Yeah, which
If
means
you pulse that magnetic field, then you get it's like conjuring motion out of thin air. Pulse Motors 101. Thanks, Chris. Love you, bro.
it's not ours.
No?
Yep.
Okay. Well, that's annoying. You can turn that off anytime.
It's coming from there.
Right.
Because if I open the door, it'll turn louder.
There it goes.
Fine, it stopped.
All right. So we're going to move this coil in here, and we're going to try and get some readings off of it at, 2,500 RPMs with the littler magnets, though. So I'm not expecting too much. But I had my 6 magnet rotor moving with these coils.
Oh, we got a new comment.
Yeah, it's a moderator, my brother. A fan.
Sometimes he'll be over for the lives, and if the camera moves often, that means he's in here. Or it's probably just me.
All right, let me turn this on.
Yay. We're going on this one too? Or not?
Just hold on, buddy.
Okay.
We're definitely gonna turn it on. I need to get this position.
You can get it set up right.
Oh man, I have a feeling these are N52s. This actually might be better than I was expecting.
That's gonna have a lot of energy.
$15, $16, $17. I'll keep you posted.
It's working. It's working.
What's that say?
That says 22, 23 volts. 23 so far. We're going up higher. Like that. Alright.
All right, we're up to 40 volts off the coil AC.
40 volts. I can go up to 25. This one
50. It's not even lined up properly, but it's getting there. It's getting there.
So fast that's going.
55.
I bet the people that are watching this can't see that moving. They can only hear the noise. But if you have very great eye vision, you can see that.
So this is 6 volts in, about 2 amps, 66 volts, 2080 RPMs. 67.
We're going for 67 volts.
70.
volts.
Oh, yeah.
This is going fast.
Don't touch it, please. Please don't. Just don't touch it. All right. 2,325.
Milliamp. It's just like milliseconds, but it's called milliamps, I think.
$75 volts. Off of these little magnets, man. That's freaking cool. And this is just standard single file wrap. 18,000 turns of 32 gauge with the soft iron core. That was satisfying almost. Very good.
See, yeah, 75 volts is to the point where it just goes super fast. A lot of people won't be able to see that moving,
So
but they will be able to hear the noise.
rotate it like so, Brian.
Let's go see how much new comments we got.
Like that? Alright, let's do it. Let's pull this out so we don't run a bunch of amps right off the bat. We'll turn it up to like 5. Start it. Okay, we're up to 6, 7.
We need to get about to
It's going
90.
up a lot slower this way. I don't think the magnets have the reach to hit the core.
We got
And they're
8,
like that.
got 8 likes up there on the TV.
See the distance increased between the magnets and the core when I shifted it. 10 volts. Let's move it a little bit though.
Oh, Chris just dropped another comment.
14 volts. No, let's do this.
Bye.
Bye.
See you in like 5 minutes.
Okay, 48 volts like that. I'm sure if the magnets were a little bit stronger, that it would been able to pick up on the magnetic flux on the core more so than it did. Okay. I'm just shocked about how well these coils are working. They're so different from what all the other stuff that I do, though. Yeah, no problem, man. I was, that it's cool. Bring your idea. Keep bringing them. Bring it on, Brian. Bring it on, man. We're gonna figure something out. You got a lot of good ideas floating in that head, dude. It's cool. I tried with the north-south part of the magnet facing up, and the south side facing this way, north side facing this way, and then I spin it this way, and it worked. It worked really well. Only the amp draw was twice what it was with the magnet facing out. So yeah, but that was cool to try. It was really easy to do. Quick and quiet. Oh man. Yeah, I'm really happy. I thought the series circuit was going to blow it out of the water, but I mean, it's pretty equal with the tip 42s anyway. 2500. We're going to get some 2444. That's right. We got 2500 with the that's awesome. So another thing, and I know this is how I know that the coils are awesome. This rotor works now. It works pretty well. Mm. It's a north-south configuration. I can't get the things to gyro very well, but you got these these magnets right here holding these ones face out. And these electromagnets are really freaking powerful. They can be more powerful, but we'll work on that. And just add like 2 more layers, and it'll double the power. Seriously, because it's right on the core. So that one was 2500. This one won't go that fast, but it looks really cool when it's moving. Just gonna move these electromagnets into place. Alright, let's give it a shot. Parallel. I've never run this parallel before. I've run it series circuit. So you pull it out, and you only hit the ones in the corners. You push it in, you hit all 8, but it's north-south when you hit all 8. And I'm pulling like 3.5 amps when I push it in like that. I know my transistors can't handle that. See, I mean, just look at how smooth these coils are operating everything. It's awesome. And these are not bolts. They are soft iron rods. And pull it back as far as I can. And still have contact. Oh, I gotta change that battery. You hear that thing squeak? It's like it was choking or something. All right, 0.5 amps. Let's turn it up. Nine volts. 1.7 amps. Hello, robot. I do remember you. Yes. Hi. Check that out. That's awesome. Oh, squeak. 1.6 amps and 9.25 volts. See, when I push it in, the gyro part gets affected by the reed switch, and these fire at the gyros when I push it in there. But I need a lot more wire on these coils before I can really do that effectively. Because I got to be able to turn it up a little bit, or you're not going to get the oomph that you need to make those things spin. Because you really got to push them to make them move. I think I might have just blown it. But I got tons more transistors. We'll see in just a second. I don't really smell it. Good idea. I like it. Let me see if I gotta change the transistors for first, and we'll see what's up. Yep, something's fried. All right, let me change those out real fast. Oh, now I smell it. Now I can smell that. Woo wee! All right. Dang. Would you guys like me to hook up the series circuit? This axle? No, I don't have enough faith in 3D printers for them to print an axle. Axles are smooth, you know? All right, let's see if I lined up those holes right. I don't like the black breadboards because I can't see the holes very well. All right, we're gonna try moving the reed switch around a little bit. Whoa, 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 what's going on? Something must be touching. Let's make sure everything is not touching. I don't know. Looks good. You know, it looks clear. I thought you said it was clear. I said it looked clear. Damn. Something's not lined up right. And I had a feeling that might happen. All right, I think I got it now. Yay. I might have burnt the switch. Looks like I burnt the switch out. For my apart. These are new coils. I'm not used to them. And I think I'm going to want to run the series just so there's a little bit more resistance. Yeah, I don't even think I can. Yeah, I can't. All right. See how quickly I can do this. That was pretty fun, right? 2,444 RPMs. You saw it. We'll be underway in just a moment. We're going to see how long it takes me to set this up. I'm not timing myself, but somebody might be. All right. And then boom, it's like it never crapped out. But here we got, this is the part. All right, now we just need to make sure that the one base that's plugged in is going to the right transistor. Bam. Man, I Doesn't seem to want to work now. You mean behind it or something like that? Yeah, I've tried that. Alright, let me clean this up. We're just going to use one transistor for right now. It's hot. Kind of like it though. Alright, so let's pull this out. Pull this out.
That's the last time I ever did. Ooh, that's good.
Oh, come on, man. Alright. What's up, little man? Alright, I gotta back this out a little bit so I can get in here. Alright, so we're going to start from the beginning and put this over here a little bit. I don't know, that's going to be right where I'm standing, but I'll try and be out of the way for most of this. Alright, so we got green wire from the power supply right here. It goes up into this coil. And then this green one goes into this coil. And this red one goes into this coil. So that's all good. This red one goes into the collector. I don't like how small these are. Okay, so that's the collector. Yellow is the emitter, so we'll plug the yellow one in. And then the red one here is the power or the input to the reed switch. I put that on the collector. And then the output to the reed switch I put on the base. Yeah, this is really hard to see. There, I got it. And here's the base connection. Fudge, man. This lighting really sucks in here. It's terrible. I've never really liked it. This is better than being in the dark, though. Did I get it? Nope. Man. Got it. Oh, that sucked. Black breadboards. Who came up with that? I still don't know whether or not it's going to work. Let's see. Nope, there's something not right. I don't even know what to do. I'll try a different transistor. It really doesn't seem like that's the problem, though. I wanted to like put 3 of these in parallel and then connect the series circuit to that. We might get around to doing that. Heck yeah. We just gotta get it back going. 2444 RPMs is our record so far today. Oh, we do have action. Turn it up. Series circuit. All right, the amps are up now. You can kind of hear the gyros. Let's get some speed before we start playing with it. Oh, that's fried. Oh, I can even see the discoloration. Haha. I don't even know about. We should pick a size that we want to do and stick with it because I'm going to glue these down. So do we want to do an 8-inch or do we want to do the little one? That's all I need to know right now. Where did my little baby go? There it is. There she goes. Either this one or the 8-inch size. All right. I guess we'll stick with the 8-inch. All right. There was a little one that went so fast though, but we're gonna stick with the bigger ones for right now. And these coils are like really, really short. And pretty thick too. So like cranking it, that's why we are where we are right now. Because I turned it up. I need, yeah, you're right. I need a little bit more wire in here. That's for sure. Dun dun dun. Yeah, and that transistor is hot and fried, so I'm just giving it a second to cool down, and I'll switch it out. I've got some better, bigger, more powerful transistors on the way. These are just, we're just gonna mess around with these. I got 3 packs of 20 tip forward 142s. But as you can see, they're not birds with a feather. I'm talking about, I don't know. I have no idea what I'm talking about, man. I think that everybody that has a mind for this kind of stuff is kind of on the same level, honestly. But I'm gonna need to hacksaw some glue off of the bottom of this thing in a second. Just all the changing on the fly. And you know, who does that? Changes things on the fly. Nobody. Nobody really does that. Except me. Everybody already has it planned out before they even start building it. And it's like, yeah, that's good. Yeah, I want to do some things like that, maybe once or twice in my life. All right, let's crank her. So you got north and south action happening here. All the gyros are south and all of the other magnets are north facing. There we go. Turn the other way. That's a pretty good spot, actually. Holy smoke. We can turn it up now. Because we're down to 0.6 amps. Nine volts, 1 amp. Here, I'll shift the camera so you guys can see what's going on with the power. That's sweet, man. That rotor is tight. So we got batteries, and then just over there we got the two power supplies right there. Oh, dang. We lost a gyro. I think I know which one it was, too. Yep. Oh, I wish I could have caught that on camera. That's my fault. And we lost a nubby too, so voila. it broke during the print, and I glued it, and there it is. Glue does not hold at high speeds. No, magnets don't move themselves. Magnets do not move themselves. You have to move a magnet into the field of another magnet in order for that interaction to even take place. Seriously, a magnet is a latent object unless it's moved into. I'm not even going to get into it. Unless there's something interacting with it, it might as well not even be a magnet at all. Oh no, we got the nub still. Sweet. Oh no. I love this rotor. It's very smooth. We're gonna build another one just like that with cubes in the gyros instead of little flat squares. All right, let's see. This is probably all going to collapse in on itself because the glue is not strong. But let's give it a shot. Yep, bricked it right up. Okay. We gotta change a few things anyway. Woo! Man. We need 120 degrees now. Anybody got an on-the-fly idea on how I can strap these things down without using glue? What kind of cost are we talking about here, guys? I mean, talking about a monetary cost? What are we talking about? I don't think this is going to stay. Awesome, Jack. Velcro, you the man. All right, so I will buy some Velcro of extra super strength. All right, it stayed. Yay, that's one. But these magnets here are really dope, like powerful 1-inch cube magnets. The magnetic field on these beasts are pretty thick. So we're just going to press that down. Well, this Gorilla Glue here is military grade, yeah. But I thought all I needed to do to make this work was one neodymium magnet and some chewing gum. MacGyver it. Wow, if this works, man, this should be pretty cool. Because I got them in closer than I've ever gotten them in before. But then again, our transistor is not very strong. It's a tip 142 of the small, small size. Yeah, heck yeah. You just got to put it in the right spot, attach that neo magnet in the right spot, and everything's going to work out just fine. All right, I think we're good. Let's give it a spin. We're at 9 volts now. Let's back it out to the edge of the magnetic field. See, these coils will move anything, and they're like teeny, they're tiny coils for the material. "12 volts. This one's so much heavier." Oh, yep, the tip 142 can't handle that. 12 volts with these small ass coils. So we got to keep it 9 max with these transistors. Whew. Yeah, I knew this was coming though, that they would get burnt out really fast because I'm so used to working with stronger ones. Sweet. Yeah, the magnets are very loosely slotted in these. They're very easy to change out and switch and everything, but they do make noise. Yeah, this is what I want to do. Now we can do this one like this. I'm pretty sure it'll have a different outcome. Alright, let's get our multimeter on. Now I was thinking about this Neo ball right here. Putting it in the middle of these and seeing if we can't get it to spin. Or maybe just the middle of like 2 of them, or make another one to have 4 of them. You know, we could work with it. Okay, here we go. Seven volts. 11, 12. 9 volts, 1 amp, 40 volts. $45. 10 volts. 50 volts. 73 volts. 90 volts. 112 volts. 1 30 volts, 130 volts. $135. I do not think this is going that fast by any means. It's got to be the transistor or something. Let's see. This is also a tip 142. I'm going to try this one. $138 volts. I want that one getting sucked in. It's hard to tell where that says 42 or 47.
Wait, where's pigs?
Alright. I just need to move. There we go. I think that's right. Alright. So hard to see that. Yes. I can already tell this one's not going that fast. But we're gonna try, see if this other transistor that's just laying on my table is gonna help. Oh no. Damn, dude, these transistors are so cheap. They're so cheap, man. And if I put a resistor on one of these transistors, it won't work at all. So I just don't bother. But, and like I said, this is, let's try one of these. That is really hot. My God. Alright, let's give it a whip. It's probably already fried. I gotta sort out the trash, if you get what I mean. And not be afraid to throw these frickin' things away because there's no way they're coming back. the hell is going on with this? I've never had to do this before. Oh man. All right. So wow. I'm thinking that the breadboard is what the problem is. I'm about to hook Little Devil back up. All right, we'll get a tach reading. I'm thinking it's going maybe 500. 450, 460. $682. $729. $860. $888. $900. Yeah, I lost it. We're down to 700. There we go. It's 800 right now. $788, 800, 825. Yeah, so moving the reed switch around helps a little bit. 850. That's like a dead zone over there. And if you get too close to these coils, they do register as a magnet to the reed switch. So they will perma stay on if you get them too close to the electromagnets. $812. But this has got to be one of the heaviest rotors that I got right now. It's got a maglev on it and everything that weighs a ton. This one doesn't go very fast, but it generates a lot of electricity. We're going to hook up little devil though. Alright, let's see if we can get a reaction the way the coils are right now. Like, can the coils reach that far? Let's see. Let's turn it on. So no, the answer to that question is no. Maybe. All right, let's get this done so that we can get some record-breaking speed going here. There's nothing I like more than having to put together stuff on live stream. There's nothing funner. And we're gonna need to get some better ideas on how to get the coils to stay put though. Something more permanent. I don't like permanent. I don't do permanent that well. Cause something is always gonna be, I'm gonna always wanna change something. So it's gotta be like, it's gonna be engineered, it's gotta be engineered to be changeable. Like on the fly changeable. Because when I get them in close like this to do the little rotor here, dang. Yeah, I knew I was gonna have some trouble with this. Come on, man. Oh, dude. You might see me struggle with this. Now you see when I go switch sides with rotors, I gotta redo it. Let's think of other times when I gotta readjust. Anyway, all the readjustments I want to be able to do without glue. I'm having a brain fart on how to get that as a possibility. Like how to make that. It's actually probably an engineering feat because people don't usually change on the fly when they're doing motors and stuff. They usually build it before they build it and then build it to a T, and then they don't change it after that. So this would probably be something new. And I'll get this last one in here, and then I'll take the rotor off, let it dry or cure a little bit, and put the rotor back on. It should be pretty stable. I'm just doing this for the timing. Almost done. Thanks for hanging in there, everybody. Hopefully we'll be able to get 2,500. This is a series circuit, by the way. Maybe 3,000. Who knows? But anyway, with the coils this close, I can put the ball in the middle here and it will jostle around like no tomorrow. Oh, come on, man. Give me a break, dude. What was that, like 3 sticks of glue already for this thing? These things not bonding to the table. Back it out just a little bit so it has clearance. It should all work now. All right, let's see. What the heck? Nope. These are not going to stay. All right, let's let that cure. Just let it sit and dry for a minute. We'll talk about the gyroscopic axial flux that I want to build. True, we could standardize it. We could definitely standardize the size of the rotor. That's an idea. It have to be 8 inches though, because that's the only printer. The printer that's working right now is got an 8-inch plate. So 8 inches is the rotor size. If we want to go biggest, because biggest is not what's gonna go fastest. Come on, man. What the hell? It's taking too long. I wanna show you guys a little devil. Oh, right here. All right, so an 8-inch disc of some kind will be placed on the shaft like this. So when you spin the shaft, the 8-inch disc will spin. Okay, hook a commutator up to that, and you can feed the coils the electricity that they need. And you put the actual flux rotor on. It's leveled perfectly on these bearings right here to be like 1/2 millimeter above the coil. All right, so when the commutator is here, I'm just in the middle of building this. So when the commutator comes, you get your power to your coils. The coils spin, say, this way, and the rotor spins the other way. You know what I'm saying? This is the gyroscopic axial flux pulse motor right here. In its infancy. So as long as these can both spin freely in either direction, this should work. Okay. So I was thinking about actually making this bigger, like all the way out to the edge, and having like 6 of them that will either trigger by these ferrites that are grade 8, or I'll have a reed switch incorporated into this build as well. This is going to be sweet. I mean, this thing on the bottom probably is not going to be the disc that I use for the stator, because it's heavy, it's big, it's not well balanced, so it's probably not going to be what I use. This rotor might actually be what I use though. This thing on the top here. All right, let's see. Sturdy, sturdy. It's kind of sturdy. All right, let's give it a shot. There's something. There's always something. No, there is something definitely awry right now. I can't really put my finger on it, but I have a feeling it has to do with the transistors. Mm. All right, so we're gonna try some of these. Some of them are tip 142, some of them are tip 147s. We'll see what happens. So that's a tip 147, and it's obviously, I can't read them, like they're way too small. I would need my phone to read something that small. Um, just trying to think real quick about what I can do. Man, so the best was at the beginning, when it was all hooked up properly. M.P.Hs are definitely the way to go. All right, it's not plugged in right. I'm telling you, I've been complaining about it since I started to stream. This black breadboard is like not cool. So we're gonna do it this way. let's see. Without a breadboard, how's it gonna do? Yeah, I don't even know, man. It's gotta be a transistor. Could be the coil. That would suck so bad. Maybe it's the switch. Oh yeah, something's not right. Wish these transistors had bigger writing on them so that I could read it. Here we go. It's probably a 147, but we'll see. So, all in all, transistors are fun, but they suck too. I mean, the longest stretch I've had with a transistor was SG, and as far as I know, it still works. Now, I should probably hook up these coils to SG, but SG is like a 1 amp system, and these coils are pushing way more than 1 amp, so I don't know if that'll help. $18.87. $19.21. $19.50. Nine volts, 1 amp. Here we go. 9 watts. 2077. 2106. There we go. Oh yeah. These coils are mean. So I don't know, when I get my bow jacks in, we're gonna have to set up some resistors on the coils. Something like that. Hey. We're just playing around with some pulse motors. And it looks like trying to untangle this as I go. So that's really sweet. That was going basically 2200. And it's still really hot. I'm gonna have to start using heat sinks. Never really used one. And that's probably what's happening to all of these. Give each one of these transistors a thorough test before I throw them in the trash. There we go. So now we only have one coil hooked up. Man, I liked it better when it was plug and play earlier today. Must be a PNP. Does anybody know the pinout for a tip 147? Because it's not the same as a tip 142, and it should be. This one might be good.
Hey, you're still alive.
Yeah, I wish that the people that made these things, didn't have like ultra vision, that they could see the print that they're. So I don't know whether I'm dealing with 147s. Oh, try it in a meter. Yeah. What is it, like 0.7? Is that the magic number I'm looking for? All right. Oh, hopefully this is the right one. I would be using these little ones more. But I got a hook. All right. I guess this will have to do. And I would not consider this a failure. I've rooted out so many bad transistors that I had just chilling around. This has been a really good day for me. So I'm sorry if other people are disappointed, but this has been really helpful for me, going through all these transistors like this. I've been finding out the tolerance of my coils. Like 9 volts appears to be the high end. See you, son.
Bye.
There we go. Yeah, that's the tip for 142 is exactly the way most of the transistors are. 147 doesn't appear to work the same way though. It is a PMP, but now I'm almost positive it's the switch. Like, all this sensitive crap, one thing blows and you don't know what it is until you switch everything out trying to find it. I mean, you should have a pretty good idea by now what it is blown out, but I don't know. I'm obviously missing something. It was working so well earlier for those of you that were watching earlier. Oh. But I had to see whether those coils would work with the bigger rotors, and they do. They do very well. I just love how wires get under wires. And I'm going to get rid of this black piece of crap. I mean, I can't tell whether those are lined up or not. All right, so we're gonna try this one more time, and then we're probably gonna call it for the night, whether it works or not. And then we're gonna clean up. That's something that we don't usually do, but we're gonna start doing that. Thank you, Brian. Pulse motor mayhem. This is a pulse motor. It's a 120-degree pulse motor. All right. What the hell? Yeah, something. I don't even know what it is right now, but I'll figure it out. I know this sounds weird, but this has been a great workout. Oh, and I left the power running. What a dumbass. Because there was no amps running through this thing. Yeah, this isn't working. So frustrating sometimes. That's a new switch, so it's not the switch. I must have something confused over here though. All right, let's try this. Gonna hook the series back up. It's probably not gonna work, but we'll see. Usually when I go to bed, the situation presents itself. The solution, I mean. Yeah, this is not gonna work right now. Look at this frickin' mess down here, man. This is so irritating. How the wires just like make little knots. Gotta get rid of some of this crap. But you know, it's a process. I've been working on it. I'm gonna get connectors for my coils because the ends keep breaking off. And I figured if the ends were just really small and connected to connectors and then attached to the coil base, they wouldn't snap. Man. There's no power going through the frickin' switch.
It was Play-Doh.
Son, do you mind? Alright. So I think that's it for right now. I changed it around enough times that it just said FU. If you don't think that these things, this is probably why people build them the way they build them, and they don't mess with them after they're done. is because they don't like being messed with. Pulse motors have emotions, they have feelings. Obviously, this guy didn't like being fucked with. We got some feedback registered. Yeah, this switch is... I'm not going to glue this one on, but it might just be a bad switch. I've been looking for that too, and I haven't seen any anywhere. I hate wires that do not do what you tell them to do. They do whatever the hell they want to do. And sometimes, just sometimes, what you want to do and what they want to do are the same thing. Just sometimes. Don't get your hopes up. You know, I'm going to try something. I'm going to try something else. Try to keep it in in the circuit here. But I'm going to not charge this from the... We're going to do it from the power supply. Let's see what happens. All right, that's it. I have no idea what's fucking going on here. I don't know what happened. I don't know what's going on. There's no wires crossed anywhere. Could be melted enamel. I mean, my amps to get up to like 8. So irritating when things don't go as planned. And you wanna make it work at least once before you leave, but I'm not even gonna bother. I'm really sorry, ladies and gentlemen. If you were here when we started, it was gold, man. We got 2,444 RPMs out of this little machine right here. We're gonna try and get 5,000. M.P.H. Senior is dead. Thank you very much. Asshole. Think you're funny? Sorry, ladies and gentlemen. Bye now.